let's jump in right into a couple different applications because we want to talk. I think we're talking. We've got field trials. Because your team provided me with some notes here that I wanted to jump into. Let's start with the mine backfill.
Okay.
Can you kind of lay the landscape of what we're talking about?
Yeah. So mine backfill is a critical component in underground mining operations, modern underground mining operations, wherein the operators use a cement or a cementitious binder to treat the waste rock or tailings and fill the stopes, which would enable them to enhance the ore recovery and also minimize surface disturbances such as tailing ponds. So in a gist, that's what mine backfill is. And our goal with GreyBond is to have an alternative for the cement or cementitious binders that are used in these systems.
So in these backfill systems, what have you done comparisons of what kind of reductions you're getting in that specific application?
Yeah. So that is the process that we're engaged in with several mining operators throughout North America. So every mine is different. The performance requirements are different. The goals are different. Our objective is to make sure that we meet the desired, end goals and also address directly the pain points of the mining operators, working closely with them, right? So in terms of cement replacement, we're looking at anywhere between 35 and 50% cement replacement in the case studies that we have done so far, and that includes both lab studies, internal and externally validated, lab studies, and also field trials, right? So, based on the proportions of the GreyBond binder that we use typically for mine backfill, we're seeing anywhere between 30 to 50% reduction in the greenhouse gas emissions.
So when you're saying, but the 30 to 50%, or 30, do you say 30 to 70%? That means that of less cement being used and using a GreyBond?
Yeah. So there's two components, right? So the reduction in greenhouse gas footprint is going to be determined by how much cement you replace,
right?
How much cement or an incumbent binder that you replace. In certain instances, the incumbent binder is a combination of cement and slag, or some other system there. So the amount of cement or the incumbent binder that you replace. And number two is also the formulation of GreyBond that you use is also going to play a role in the reduction. So I present numbers that are broadly in a range. You'd notice that, I mentioned 30 to 70%, 30 to 50%.
It is quite a range.
It is quite a range.
Understand
so that is where we're working on developing the LCAs and also EPDs, environmental product declaration documents for GreyBond. And that will actually give us more of a accurate estimations.
How do you go about these though? Do you get are there third-party companies, like organizations that'll come in and do the testing for you to really make sure that your numbers, you're getting it, obviously that it's accurate, but also sort of informs you of where it's at as a product in the market?
I mean, you're asking about the greenhouse gas footprint or performance like strength?
All the above, yeah.
Yeah, okay. So, we do work with third-party engineering firms and consultants for determining the strength in situ. After the trials, we sample materials and go back and test the strength. So we rely on external engineering firms for that. We also have in-house capabilities, but we want to make sure that and the mining operator would have the same expectation that said that the results are independently verified. So that's where the additional credibility comes into play. And with regards to greenhouse gas emissions, we're working our HSE team is working with external consultants to define the GHG profile of GreyBond, and that has to be application specific, and also depends on where we produce GreyBond and what goes into the production of GreyBond. So that's a pretty thorough analysis.
Sorry, what do you mean by that? What, where you produce it?
Yeah, I mean, so GreyBond produced at location A, and location B is going to have some differences.
Right, I see.
Depending on the production practices, that type of equipment, and all those.
Right, so you're matching up production practices to application, and it's always there's a
Yeah.
process there that always has to happen.
Correct. Yeah.
right.
So it has to be a site specific, project specific analysis.